Hi guys. Tonight we're going to look at relations and function, and we're going to answer the question, is a relation a function? So far, all of the sets of ordered pairs or the tables or the sequences that we've been looking at have been relations. They have an input and they have an output. So before we begin with the notes, I just want to define two words. The first one is a definition of a relation. And a relation is just a set of ordered pairs. That's all it is. It's a set of ordered pairs that we can graph on a coordinate grid. So if I have the ordered pair 1, 0, the ordered pair 2, 2, and 3, 5, that is a relation. So what's a function? A function is a special type of relation. So a function is a special relation. All sets of ordered pairs are relations, but not all relations are functions. So it's a special relation in which each input has a single output. So what that really means is that in our set of ordered pairs, all x values are different. So we're going to take a look at how can we tell if a set of ordered pairs is a function. And how are we going to determine that? We're going to look at our x values to make sure all our x values are different. Does each input have exactly one output? So if we look at this relation up here, which is a set of ordered pairs, we're going to look at our x values. Our x values are 0, 2, and 3. They're all different, so this is a function. If it's a function, we can write a rule. So let's move on to the notes. So functions can be shown in three different ways. A function can be shown as a table. We were looking at input and output tables in the last set of notes. We can write a function as an equation. We can show a function as a graph, and we can also use it as a diagram. And this diagram is called a mapping diagram. And all it does is it maps our ordered pair. So it maps, just like in this case over here, the 3 gets mapped to the 6 because it's in the same ordered pair over here. The negative 14 gets mapped to the 28 because it's in the ordered pair over here. And then the 9 3/10 gets mapped to the 18.6. It's just matching up our domains and our ranges, and we call that a mapping. So all of these, the table, the equation, the graph, and the mapping diagram, all represent the same thing. They're all the same equation, the same set of ordered pairs, the same mapping, and the same graph. So how do I know if this relation, which is a set of ordered pairs, is a function? So let's take a look at these 4 examples down here. So when I'm determining whether a set of ordered pairs is a function or not, I have to look at my list of inputs, my domain, or my x values. So you have to ask yourself this question: are all of the x values unique? And they are. So that means that this set of ordered pairs, this relation, this table, is a function. And yes, it's a function because all x values are different. And that means that each input has exactly one output. So why do we need to know if this is a function or not? Because if it's a function, we can write a rule, just like we did up here. If it's not a function, we can't write a rule for it, which means if we can't write a rule, we can't find more points for the function, which means we can't graph it. So when we're looking at a mapping diagram, like this one over here, we have to determine if all the x values are unique. So this is our domain, and this is our range. But before we do that, we can't just look at this list of numbers here. It's easiest to write them as a set of ordered pairs. You can write it in a table, you can write it with brackets. So for our domain, we have the first one is 2, and that gets mapped to 1. So that's our first set of ordered pairs, which is 2, 1. 2 also gets mapped to 3. The -1 gets mapped to 4. And the 0 gets mapped to 3. So now we want to look at our domain and look to see, are all of our x values unique? Are they all different? And the answer is no. So that means this is not a function. And it's not a function because these two x values, these two domain values repeat. These two domains are mapped. They have more than one output. The 2 has an output of 1, and the 2 also has an output of 3. So let's take a look at this relation, this set of ordered pairs. We want to determine if it's a function. So we're going to look at our x values. So I'm just going to highlight them. It's already set up. We have -1, -3, 5, and 0. So if we look at our domain, our x values, our inputs, are they all unique? And yes, in this case they are. They're all different. We have -1, -3, 5, and 0. Because they're all different numbers and none of them repeat, then we can say that yes, this is a function, because all x values are unique, or all x values don't repeat, or each input corresponds to only one output. So last example, and again, when you have either a mapping diagram or a graph, the easiest thing to do is to write down, either make a t-table like I did in example number 2, or write down your sets of ordered pairs. So we'll write this one down as a set of ordered pairs. So my first ordered pair is 1, 4. My second ordered pair is 2, 3. My third ordered pair is 4, 4. And my last ordered pair is 6, 5. So again, I want to look at my x values. Are all my x values unique? Does each input have a single output? And the answer is yes. This is a function. Now one thing I want to mention is the y values. So if you look at the y values here, the 4 repeats in the first set ordered pair and it repeats in the second ordered pair. I don't care about that. I don't care if every single y value is the same. I just have to worry about the x values. The x values cannot repeat. The y values can repeat. Okay, last thing with functions. Sometimes it's not easy, like on these 3 graphs down here, to determine what the ordered pairs are, because these graphs don't have a scale. So there's no scale on the x and the y axis here. So if that's the case, we can use something called the vertical line test. Sometimes it's referred to as the pencil test. Sometimes it's referred to as the spaghetti test, because this piece of spaghetti is a vertical line. So keep in mind that a vertical line goes north to south. So this is what the vertical line test does. If I can draw a line through this graph from top to bottom, parallel to the y-axis. If my vertical line hits the graph in more than one spot, that means that this is not a function. Because what that means is that if I were to graph, or if I were to write these ordered pairs, this ordered pair might be -3, 5. This ordered pair might be -3, 1. And this ordered pair might be -3, -2. So because this vertical line hits at this point, and this point, that means I'm going to have domains that repeat, which means it's not a function. And that vertical line can go anywhere. We could have the vertical line here. It hits the graph at these 3 points, which also means it's not a function. So let's take a look at the second example. And this one is kind of tricky. So if I draw my vertical line here, it only hits the graph once, so that means yes, it is a function. But what happens if I draw my graph through this line, or through this point here, and this point here? Well, it hits the graph here, but since this is an open circle, that means that that point is not included. So really it's only hitting the graph one time. It's hitting the graph right here. Right here it happens to be going through that point, but that point has an open circle, which means that number is not included, just like on an inequality graph. So then this one would be yes, it is a function. So let's take a look at the last one. I want to draw a vertical line, and I'm looking at this part of the graph right here. So I'm just looking at this part right here, not the x and y axis. If I take my vertical line, it hits the graph once. If I take my vertical line here and move it over, it just hits the graph once. If I move my vertical line over here, it just hits the graph once. So then yes, this is a function because it passes the VLT, and the VLT is the vertical line test. Okay, now it's your turn to determine in multiple choice question 1, is this a function? And my suggestion would be to make a table of ordered pairs for your x and y. Number 2, in your own words, how do you determine if a graph is a function? And we're talking about a graph. So what did we do in that last slide to determine if a graph is a function? Please remember to enter your answers to your questions on the Google form. Have a good night.